We had that argument today.
Yeah, the problem is really about teams and the writer wants about simply starting switch. Yeah. I totally got that.
I said hi.
You gotta do what you gotta do.
You don't get the copy anyway, it's just there.
Guys, if you can turn to page 27. So we worked through these problems involving roots. These are the ones that are the most involved. Let me kind of recap these the steps. We'll do number 10. Number 10 is just finding the roots of 1 plus 0i. So roots of unity. Unity is just in this case it's the special name for a complex function or a function complex expression that is 1 plus 0i. So we call it roots of unity, or they call it unity. This week, our test is going to be on Thursday. Okay, so test is Thursday. So pushing it back one day. Tomorrow, we're just going to do an activity. If you're here, just practicing. We're going to turn this polar coordinates into a short game. If you're here, we'll only have 20 minutes, so it'll be a partner activity. It won't be for a grade, just practice and then just to kind of have that activity. Wednesday, we'll do a full test review, and then Thursday is the test. If you look on page 34, okay, you're responsible for all the formulas, so you got to memorize all the formulas that we're working with, except for the distance. I'll give this distance. I'll leave this up here on the board. Okay, so from polar to standard, from standard to polar, hopefully you guys are getting comfortable with Pythagorean theorem, inverse tangent, r cosine theta, r cosine theta. We do need to review distance between two complex numbers, midpoint between two complex numbers. But today I really want us to just focus on these recent operations that we've been working through: multiplication, division, powers, and roots. Okay. So if you guys can turn page 27, let's do number 10. But before we do number 10, let me run through the steps for number 4. So the fourth root of 4 root 3 minus 4i. The first thing we do is we gather the radius and the theta. Okay. Because we want to get r and theta to get into polar form. So to get that radius, we do Pythagorean theorem, square root of a squared plus b squared. You get 8. Theta is inverse tangent of b over a. I make sure you recognize which quadrant that it's in. Once you recognize the quadrant, then you get in that quadrant. In this case, it's easier to start off in degree mode, and then once you get that degree that you're looking for, then convert it to radians. You can always get that by dividing by 180, and it's 11 pi over 6. So we know that our complex number of this standard form is 8 CIS 11 pi over 6. Now from here, we want to find each of the solutions, right? So fourth root means we know we have to raise it to the 1/4. So it's the fourth root of r, but then you're dividing by 4 for your angle. So dividing by 4 is same thing as multiplying by 1/4. And then when you get that cleaned up, then the fourth root of 8 cos CIS 11 pi over 24, that's your first solution. Once you get your first solution, then you want to find your other 3 solutions. And your other 3 solutions are all going to be evenly spaced apart from each other. So the way you get to those evenly spaced angle measures is you take 2 pi and you divide it by however many solutions you're looking for. So I want each solution to be separated by pi over 2. So you have one solution. All you do is you find the other solutions by keep adding pi over 2 to the previous radian measure. So 11 pi over 2, 11 pi over 24 plus pi over 2 gives us 23 over 24. And then 23 over 24 plus pi over, plus 1/2 gives you 35 over 24. 35 over 24 plus 1/2 gives you 47 over 24. Yes?
At the beginning of the problem, why did you multiply 330 by pi over 180?
Because at the top it says answer in polar form. But I think it is helpful to start off in degree mode because degree mode will get you to a number that's more easily recognizable. So get that angle figured out, convert it to radians, and then you can do the rest in radians. Okay, so it's a complex formula. I don't want you to use the formula. I'd rather you just go through these multiple steps that we're doing, right? To kind of, make everything manageable rather than just, so rather do that than talking through that complex formula that you see at the bottom of page 34. Okay, let's look at number 10. We'll work through it step by step. Yeah. Oh, I'll look at the 1/4. So we know this is 4th root. So 4th root means that you want to raise it to the 1 over n. So here's the formula we're using here. Did I put this? Okay, it's this one on page 25. It's this formula. You raise the radius to that root, but then you divide by that n value. So because it's a fraction, I did 1 over 4 times theta.
And what about when you got 4 and
4th root of 8. Is that what we're asking about?
Yeah.
4th root of 8 is same thing as 8 to the 1/4. So I could have written it as 8 to the 1/4, or I could have had it at 4th root of 8. Either is acceptable. So this is the radical form, but you could also write it as this. It's the same thing. All right, are we okay with number 9? All right, so again, unity is just another, the meaning of unity is 1. So when you see unity, just know that it's talking about this complex number 1 plus 0i. Okay, so basically we want to find the 5th roots of 1 plus 0i. Okay, so you go through your same steps, find your r, find your theta. Square root of a squared plus b squared. Now this is an easy one to find. If what you're graphing is landing directly on the axis, then don't use inverse tangent. Just graph it, right? So here 1 plus 0i, that means you are 1 unit on the positive x-axis. What degree measure is that? 0, right? So if you're over here, that's a 0 degree, so your theta is 0. Okay, you have your r and theta. You get it into polar form. So now it's the 5th root. So 5th root means I have to take that r, raise it to the 1/5, or take the 5th root of 1, and then divide my theta measure by 5, right? 5th root, so n equals 5. So that's my first solution. I'll go ahead and make that a little bit cleaner. You know that 0 over 5 is still 0. Or you can abbreviate it as CIS. Yes, question.
Get the
Oh, you mean n equals 5?
yeah.
Yeah, it's fifth roots. So however, whatever if it says fourth root or sixth root or seventh root, that's going to be your n value. Yeah, but because it's roots, you know it's going to be 1 over that number, 1 over n. Okay, fifth roots of unity. We know that we want all 5 solutions to be evenly spaced around the entire circle. So how do we get there? Yeah, 2 pi divided by 5. Okay. Because we're in radian, we're going to leave everything in radian. So all you do is you keep all your solutions the same. You're just incrementing your theta by 2 pi over 5. So you just keep adding 2 pi over 5 until you reach all your solutions. I know there's a lot of writing to do, so if you want to use CIS, you can do shortcut that way. Okay. Find your radius, find your theta, get it into polar form, deal with the roots so that you can find your first solution, and then take your circle, divide it by the number of solutions you're looking for, and then you're going to keep incrementing your theta until you reach all 5 solutions. And I changed my format halfway through just to show that if you want to write it in that shorthand form of CIS, you can, or you can write that full cosine theta plus I sine theta. All right, whenever you guys are ready, let's go to page 28. Okay, so page 28, the direction says, find the product and quotient of the complex numbers. But because of the limited amount of space that we have, why don't we do product for number 1 and then quotient for number 2? Okay, I know I didn't provide a lot of room here, so we'll do product for 1. Okay, yeah. I'm gonna leave this up for another second here. I know that you guys are still copying this down, but for number 1, if you can do product, and number 2, you'll do quotient. Okay, are we okay with this page? So if you go to page 34, you see the formula there, right? So with product, you're going to be multiplying your radius, but adding adding the degrees or adding the radian measures. And then for number 2, you're going to do quotient. So product, you multiply the radius, but add the theta. For quotient, you're going to divide the radius and subtract the theta. So first express your answer in polar form, then convert it to rectangular form. If it starts with theta, we need to represent our polar form in terms of theta as well. If we start with degrees, we'll have to end in degrees. Okay. But we're just going to do product for number 1 and quotient for number 2 because of the limited space that we have here. Okay, you'll leave it like this for polar form. And if you want to get this into rectangular form, just distribute the 14 through and then resolve the cosine, the 5/4, and sine the 5/4. Okay, check number 1, see if your answer matches. And number 2, you're just going to do quotient. So with quotient, you're dividing r, but then you're subtracting your theta, right? Okay, 50 degrees is not going to be a nice unit circle value, so you just leave it in decimal form when you convert it to rectangular form. Notice that these are in degree measures, so you want to make sure that your calculator is in degree mode, and then you just distribute the 4 over 25, that whatever that decimal is, distribute it through, and then you should get 0.103, and then 0.123. Okay, any questions with number 2? Okay, number 3, we're going to use the power of a complex number. So first we're going to convert to polar form first. So we're going to find r, we're going to find theta, we'll get it into this form, and then we got to raise to the power that's given in the problem. So when you raise to a power, you raise the radius to a power, but you always do something different with theta. So in this case, we're not going to raise theta to a power, we're going to multiply theta by that n value. So we always do to the radius what the name of the operation is, but theta is always a little different. Okay, so first things first, let's find r and let's find theta, and let's get into polar form, and then we can deal with the exponent for later. So everything is in terms of radians, but I would suggest when you find your inverse tangent, leave it in degrees so that you can get that degree, that theta measure, interpret it easily, and then you can work your way back to radians. Quadrant 4, right? Which is 5 pi over 3, yeah. Once you have it in polar form, then you can deal with the exponents. So you're going to raise 2 to the 4th power, but then you're going to multiply 4 inside your theta. Okay, now when you multiply this through, what measure are you going to get? What's that going to give us? Yeah, 20 pi over 3. Now, 20 pi over 3 does not fall inside the interval from 0 to 2 pi, so how can I get 20 pi over 3 down to something that we can recognize? Yeah, good. Keep subtracting 2 until you get it to something that you recognize. All right, so if you do 20 over 3 minus 2, 14 over 3, you still don't recognize that, minus 2 again, minus 2 again. So you get a 2/3, then we get a 2/3, you recognize that because that's clearly between 0 and 2 pi.
You want me to radian mode, right?
Yeah, radian mode. Yeah, the direction will always tell you. If you see pi in your theta, you know it has to be in radian mode. But I would always do angle. If you're trying to define angle, just start off with degree mode, get that going, and then you can go back to radian mode. Okay, any questions with 3? Okay, so number 4, very similar steps. You can kind of practice through those steps and see if you can use number 3 to kind of help you recall, each of the things that we have to do here. Okay, so try number 4, and I will work through the steps for number 4 once you guys get going. Everybody okay with number 3? Okay, so here's number 4. I'm not finished with it yet, but this is what I have so far. Again, 15 power 4 is outside my 0 to 2 pi interval, so I can just subtract 2 from that fraction, and it'll get me down to 7 over 4. Okay, any questions here? Okay, number 5 and 6, we're back to finding roots. So this is where we got to go through those multiple steps, right? Okay, I'll start working on 5 and show it while when you guys have a chance to try it. Okay, is anybody still working on number 4? Any questions with 4? Okay, so here's how I started number 5. Find my radius, find my theta. Now, if your value is sitting along the axis, there's no need to involve tangent, right? You can just draw it out and convince yourself that it's either one of the quadrant measures. Yeah. Right, so we know that we were looking for 5 solutions, right? This is the 5th root. You know that all 5 solutions are equally spaced around the circle. And we are dealing with radians, so we'll do 2 pi divided by 5. So we can space out all the solutions equally across the full circle.
Okay. I'm confused where 2pi came from. Or 2pi with 5.
Right, so 2 pi indicates the full circle. So basically, all your solutions are going to be equally spaced around the circle because we have 5 solutions, okay? Because we're looking for fifth root. So the formula is going to be 2 pi over n, or 360 over n. And n is however many solutions we're looking for. So in this case, we did 2 pi over n, so that we can make sure that every solution is equally spaced around the circle. So we keep adding 2 pi over 4, so we make sure that every solution is 2 pi over 5. Right, 2 pi over 5 equally spaced around the circle. But if this theta is 3 degree mode, then you do 360 divided by n, and you find that degree measure to add to each of the solutions. Right. Any other questions with 5?
Can you explain that again?
Which part? The
How you find 2 pi?
Yeah, 2 pi. So we're always, so think of 2 pi and 360 as a full circle. And if I want to make sure that every solution is the same distance apart from each other, I got to divide it by however many solutions I'm looking for. So in this case, 2 pi over 5, 2/5 pi is the distance that I want between each of these solutions. So that's why once I have my starting solution or starting location, I'm going to keep adding 2 pi over 5 so I can make sure that they're all the same space apart from each other. Okay, try number 6. Okay, I'll show the work in a second here. Mm-hmm.
Why is it one side?
Y is
Theta. Why is it undefined?
well, 0. Yeah. So if you're dealing with something that is along the axis, don't use tangent. Just look to see where that's pointing. So here, 0, negative 81 means that I'm going down the y-axis. So this is 270 degrees, or 3 pi over 2.
Oh.
Yeah. So yeah, don't involve inverse tangent if it's along the axis. You can just figure it out by looking at the quadrants. Yeah, but if it's in one of the 4 quadrants, then you can use inverse tangent. Okay, so that's z, that's your complex number, but then you got to raise it to the 1/4, and you got to divide the theta by 4 or multiply by 1/4. Okay, so whenever you guys are done, I'm going to check pages 27 and 28. Tomorrow, if you're in class, we'll just do a 20-minute activity. There'll just be extra practice, but it'll be in the game form. And then Wednesday, we'll do full test review, and then Thursday test. Okay. I finished grading your quizzes. I will put them in the grade book, and I'll hand them back to you on Wednesday. Or if you're here tomorrow, I'll hand it to you tomorrow as well.